Okay, students, today I am continuing the chapter carboxylic acid. In the previous class, we were doing the comparison of strength of different carboxylic acid. So, in that aspect, we studied about the different carboxylic acids on the basis of their strength and the variation of strength depending upon the nature of the carboxylic acid. Today, we are taking a group of carboxylic acids. I will show you with camera and I will say you first. Acetic acid, chloroacetic acid, bromoacetic acid, iodoacetic acid and fluoroacetic acid. So we have taken acetic acid and these various substituted, monosubstituted acids. As you know, we have studied already the inductive effect. Inductive effect, that there is minus I effect. In this case, you have to consider the minus I effect. So if you consider the halogen atoms, fluorine, iodine, bromine and chlorine. If you compare the different halogens, fluorine, iodine, bromine and chlorine, you can see fluorine is maximum value of minus I effect. So more electronegative. Fluorine is more electronegative. Then it is chlorine. So just see. The first one is fluorine and the second the atom is chlorine. Then bromine and the least electronegative is iodine. Right? That is the arrangement of minus I effect. This is electronegativity character. So electronegativity character of fluorine is more than chlorine, is more than bromine, is more than iodine. So depending upon this minus I effect, you can easily explain the acidic character of these acids. Fluorine is more electronegative. Electronegative means the electrons are pulling towards fluorine from this side, from this COH2. Actually, the negative charge will migrate towards the fluorine atom. So naturally, here the minus charge will be lesser in this case because the minus charge will be migrating towards, electrons are migrating towards fluorine. So here the minus charge assembled here, occurred here will be less. So that it is easy to remove the H plus ion. So H plus ion can be easily removed in this case. And next case is actually fluorine but chlorine. Chlorine also, you can see the electrons are pulling towards Cl and here it is lesser negative, so H plus ions can be easily removed. H plus ion can be easily removed. So this, if you see this property, the first property in this one, second is here, and third one is here, bromine case, and the fourth one is in the case of iron. And in this case, as you can see, the CS3 group is supplying electrons. It will be supplying electrons to the COH group, and naturally here the negative charge will be high. The removal of protons should be difficult. So if you see this into the mind, if you keep into this mind, you can, I have written here, fluoroacetic acid is having the maximum acidity, followed by chloroacetic acid, followed by bromoacetic acid, followed by the iodoacetic acid. And finally, there is the least acidity in the case of acetic acid. Least acidity in the case of acetic. So, if you want to analyze the acidity of this carboxylic acid, you have to take only the minus I effect. Minus I effect, by taking minus I effect, you can easily explain which one is having more acidic and which one is having least acidic. So that is one part of the study on today. And if you see the other part, that the last part in the blackboard. So here I have written some acids: benzoic acid, orthonitrobenzoic acid, metanitrobenzoic acid, and para-nitrobenzoic acid. So in the examination also there will be one question giving two examples and find out which one is having more acidity and explain. They may ask the previous examples and they may ask this example. Here look at it. In this case actually inductive effect is there. More than that, resonance effect is also there. In the case of aliphatic acids, no resonance effect. But in this case, in the case of aromatic acids, there will be resonance effect also. So let us see. Benzene, you can see benzene. I have written like this, but benzene actually it is a structure of 5 structures of equivalent structures of Kekulé structures. So here you can see this is benzoic acid, this is orthonitrobenzoic acid, this is meta, this is para-nitrobenzoic acid. Which one is having maximum acidity? So in this case the para-nitrobenzoic acid. Para-nitrobenzoic acid is actually the nitro group is placed para to the COH, para position. This is number 1. And number 2 is ortho. And number 3 is meta. And the last one, least one is benzoic acid. So in this case you should understand the electron density, electron will come into this benzene ring, because benzene ring is aromatic in nature. It is having benzene, it is electron deficient structure this is. And similarly there is resonance effect also. So resonance effect also minus IR effect, that is minus R effect. So these electrons here from this COH group migrate towards the benzene. In all these cases it happens. But variation is which one is having maximum effect. So here this nitro group, suppose if it is there, nitro group is also will supply electrons. So nitro group para position, suppose it is in the positive position, this will be supplying electrons. This also will be supplying electrons to the phenyl ring, and this also will be supplying electrons to the phenyl ring. So in this case you can see the electrons are nitro group is not supplying electrons. Nitro group will withdraw electrons. Nitro group will withdraw electrons and this also will withdraw electrons. That is, the electrons are moving towards the ring. At the same time, electrons are moving towards the nitro group. So from this particular structure you can see electrons are moving towards the benzene phenyl ring and moving towards the nitro group. So the flow of electrons are towards in this direction, maximum in this direction. So here it will become less negative. This CO group will have less negative, so that this H plus can be easily removed. So this is happening. So therefore this is number 1, para-nitrobenzoic acid. Next one is, in this case, this is actually orthonitrobenzoic acid. Orthonitrobenzoic acid is also like this. This also will be supplying electrons to here. So nitro group will supply electron to the phenyl ring. COH also will have to supply electrons to the phenyl ring. So this phenyl ring will become more negative, and COH will be naturally less negative. CO will be less negative, so that H plus ions can be easily removed. So number 2, second position is here. This is known as ortho effect. This is R effect is there, minus R effect is there, and this will have ortho effect also. Number 3 is actually practically this one, that is meta-nitrobenzoic acid. Meta-nitrobenzoic acid actually there is no effect at all, only minus R effect is there, less minus R effect is there at meta position, which is known as meta effect. Meta effect is nothing but it will have less resonance effect. So here in this case also the electron movement can be explained like that. From COH group, the electrons are supplying to the phenyl ring, and NO2 also withdraws electrons, supplies electrons. It will withdraw electron like this. So naturally this is number 3. But in the case of benzoic acid, there is only resonance effect. There is no other effect. So there is no, you can say, ortho effect, no meta effect, no effect like paraposition also. So that is a resonance effect. The resonance effect is there. It is only, there is no other side group. So therefore it will be having least effect. So if you compare these all 4, we will be having 4 pictures like this. Paraposition is like this, and this is ortho effect, this is meta effect, and this side we will be having only the resonance effect. So by taking these 4, 1, 2, 3, 4, you can easily explain the acidity difference, so acidity calculations of these compounds. Let me show this in picture. So this is the compound, 3, 4 acids. Out of that, acetic acid will be having least, and then fluoro will be more, bromo, chloro number 2, bromo will be number 3, and iodo will be number 4. Only you have to explain by taking the minus I effect. In this case, the acidity difference of these compounds. That is comparison of acidity of this compound. But if you come to this picture, benzoic acid, you can see it will be having least acidity because only no other side group is there. Only these electrons are moving from the COH group towards the ring marginally. So H plus can be removed. Definitely it can be removed, but it will have least acidity. But in this case, you can see ortho position will be having the natural shifting of electron towards the phenyl ring, and ortho position there is NO2, which will be having number 2. It should be. It is not having number 2. Just see it now. The position is like this, and electron can be supplied from here. Naturally, it will be having. I think this is number 1. This one will be having number 1. Ortho effect is there, therefore ortho effect will be there. That is number 1. And then para effect. Para effect is this one. Para effect. This is number 2. Okay. Then the other one, meta effect, number 3. Least one is number 4. This one you have to explain by taking this resonance effect as well as the inductive effect. Not to inductive effect is also there. COH is the group, that is also inductive effect is there. At the same time, the resonance structure of this phenyl ring. So you can see now it will be least acidic is benzoic acid. Number 2 means least, number 1. Maximum acidity is number 1, meta nitrobenzoic acid. Second position is para. Third one is meta. And the last one, least one is the benzoic acid. So this is all about the acidity difference of this compound. And let me complete another 2 more reactions. Properties of carboxylic acid. And you can see the reactions of COH. First reaction is decarboxylation. What do you mean by decarboxylation? A removal of carbon dioxide on heating. There are 2 reactions here for carboxyl group. First one is you have to take sodium salt of carboxylic acid. This is known as sodium acetate. Not carboxylic acid itself. You have to convert it to sodium salt of carboxylic acid. Sodium acetate. One example. You have to treat with heat. You have to heat with calcium oxide and sodium hydroxide, which is known as soda lime. calcium oxide and sodium hydroxide, which is known as soda lime. So sodium acetate is heating with sodium hydroxide and calcium oxide. You will be getting alkanes. So that is very important. First, decarboxylation reaction. Decarboxylation means you have to take sodium salt of carboxylic acid. You have to heat with sodium hydroxide and calcium oxide. Heating should be necessary, and corresponding alkane can be formed along with sodium carbonate. That is one reaction. Another reaction is if you take another dicarboxylic acid, the carboxylic acid containing COH2, dicarboxylic acid, which is known as malonic acid in this case. And if you heat, then acid itself, no need to convert into salt. Acid itself at about 140 to 170 degree, you are getting monocarboxylic acid. Carbon dioxide will be eliminated. So in this case, there is no carbon decarboxylation, but sodium carbonate is involved. Sodium carbonate is involved. But in the second case, carbon dioxide itself is involved, and you are getting monocarboxylic acid. And these two reactions are there for decarboxylation reaction of carboxylic acid. This reaction you might have studied in PUC level. Okay. Another one reaction is known as alpha substitution reaction. I will show you with camera again. Alpha substitution reaction. This is known as Hell-Vollard-Zelinsky reaction. Hell-Vollard-Zelinsky reaction, which is known as HVZ reaction. HVZ. And what is the reaction? You have to take a carboxylic acid, any carboxylic acid. This R means CS3 or C2H5, whichever you do. I can put C2H5. C2H5 is nothing but CS3, CH2. And if you take this example, the carboxyl group is connected to this carbon atom, which is known as alpha. This is beta, this is gamma. Okay, and you can name like this. Alpha, beta, gamma. If you treat this compound, this carboxylic acid, with bromine and phosphorus. Bromine and phosphorus. Otherwise, phosphorus tribromide. Followed by hydrolysis. First you have to treat with bromine and phosphorus or phosphorus tribromide. Followed by hydrolysis, that is additional product. You are going to get alpha substituted product, that is CH3, CH2, CH3, CH2, CH2, COH was taken. What is this acid? 1, 2, 3, 4. Acetic acid, formic acid, acetic acid, propionic acid, right? Butanoic acid. So if you take this compound, if you treat this compound, and you will be getting a product in which one bromine atom is substituted one hydrogen from the alpha carbon atom. One bromine atom substitutes one hydrogen atom from the alpha carbon atom. So this CH3, CH2, CHBr, CH. A selective reaction is Hell-Vollard-Zelinsky reaction is a selective reaction, which is also known as alpha substitution. One of the hydrogen atoms from alpha carbon is substituted by halogen. So this is also important reaction from the examination point of view. Students, I am very sorry to say that nowadays you are not giving very importance to the online classes. I do not know what is your plan. What are you doing there? You are not seeing the classes properly. If you see continuously the classes, you can understand the things, reactions and all the things. And you have to refer books also. Number of times I told you, you have to refer books. Tumakuru University has announced the date of examination in the month of February and March. I don't know how we can conduct the examination. I am not in a position to even think about that. We do not know what to do because no labs started, no offline classes started, and the university are saying that they are going to start the examination in the month of February and March. And you people are not visiting, seeing the online classes. See, this mentality you have to change. Otherwise, you have to come into the line. You have to. I am not taking any Google Meet classes because morning at 10 o'clock or 11 o'clock you will be somewhere. You cannot come to the computer. You cannot come to the computer at an exact time. And the computer at that time you do not know the network also, whether the network is available in your native or not. Such things are there, but in YouTube classes it will be there in YouTube. Permanently it will be there. SSLGC chemistry. You open it and you see my classes. My classes are registered in that particular channel, SSLGC chemistry. And you are seeing previously, correctly. But nowadays I think you are not interested in seeing the online classes. This mentality should be changed, and you have to see the classes very regularly. Then only you can understand the things. See, no other way we can help you. So whatever we talk in the classroom, you have to accept it. And whenever you come to the college, we will clear the doubts. I know there are some limitations. 100% you cannot understand certain things. Such things we can clarify in the classrooms. Otherwise, you come to the college in the middle. They only will be objective. Even now also you can come to the college sometimes and clear your doubts. Doubt clearing. For doubt clearing, government has permitted second year and first year students, they can come to the college and they can correct the doubts and all, clear the doubts and all. So, once again I appeal to our students to see the classes regularly and until the offline classes started. Offline classes also will be starting very shortly. I don't know when it is. Maybe in this month, the end of this month, who knows. Maybe from 2021 January. So therefore, you have to, just for time being, you have to see the classes very rarely. Thank you.